Hello. Today I'm going to demonstrate how you can do analytics on event streams. If you take a look at what's running in the background, on the left I have a Java program inserting events into a database, and on the right I've got a Jupyter notebook. And the chart is a way of showing you that we can do historical and real-time analytics. So in this case we're using the latest time slice to represent current data, the events that are being fed in. And we can see that the average in the count is constantly changing as we process that data. The older time slices represent doing historical analytics. So it's a fairly simple example, but the important thing is the technology being used. We want to use something that can handle high-speed ingesting of events, and we want to be able to do real-time analytics. So what we built this with is Db2 Event Store. And I'll show you how you can manipulate the Db2 Event Store, how we can do inserts with the Java program, and how we can chart the analytics using Spark SQL and a matplotlib chart. Let's take a look at the code pattern. As usual, this is a public GitHub repo under IBM/Db2 Event Store taxi trips. If you go there, you'll see step-by-step instructions where you will install Db2 Event Store. It comes with Jupyter notebooks. You can then load up the notebook that's provided, and you can run the Java code that's also provided. Now if you look at the steps, once you follow the instructions to install the event store and clone the repo, we'll just use some simple Maven commands to run the Java program. So do a Maven clean, Maven install, and then we'll do a compile and exec. And this Java program is set up so it will run like a daemon. It's going to sit and wait until the notebook asks it to start inserting data. For the compile and exec command, you'll want to copy paste it from the README. You might want to change the IP address there to be your actual host IP address. For the Jupyter notebook, the Db2 Event Store comes with Jupyter notebooks, so you already have this environment. What we're going to do is we're just going to add a notebook. So you click on Add Notebooks. Out of your cloned repo, you go into the Notebooks directory and take the Taxi Trips notebook. We'll open that up, give it a name, and press Create Notebook. So now we have our Java daemon running, and we have our Jupyter notebook ready to interact with the Db2 Event Store. You'll need to edit the notebook to set the host IP address. So this notebook is running in a container, but the event store is running on the host. So you'll need to make sure you fill in this IP address before you run the notebook. So I actually just ran this, but I'm going to start over and run everything again. You'll notice that the data feed on the left is going to start over when it gets a message from the notebook. So I just did a run all, and as we go through the cells you can see that this notebook is a good example of how to interact with the event store. So we're actually going to create a database. So since I ran this before, I uncommented the drop database. So I'm going to drop the database and create a brand new one. And then I will create a table. So this is the table schema. So we've got a new table. A little bit of code here shows you how to list the tables that you have. And then this part with the sockets, this is where we tell that daemon to start inserting data. And you'll see it just kicked in again. So it's starting over with a new database and a new table, and it's inserting data. Now let's query the table. First we need to connect to the event store, and we do that by creating this event session to connect to our database. Now we're going to do some simple queries. Let's start with a count star, so we see the total number of rows that we've inserted. And then let's do a little aggregation. So this is based on Apache Spark, so we can do Spark SQL. We'll aggregate by hours and minutes. The data that we've been feeding in will show up in 15-minute time buckets. So now we have the time slices, the count, and the averages. If we do the same thing in a little bit of a loop, we can see that last time slice is the one that's changing. We're using that to represent now. It's not exactly a now timestamp, but the last time slice is the one that we're feeding data into. So you can see the counts growing and the time slices are increasing. So we're moving forward in time. If we take the same thing but do it graphically, here's the better example of a little bit of analytics with historical data and some current data that's responding to an incoming event stream. So this is matplotlib with animation. We're taking the same query and you see the existing time slices, they have a count and an average. But that last time slice, the current one, the count is growing and the average is constantly changing. Okay, so while we let this run, let's take a look at what we've done so far. So we have a program that knows how to insert data into this event stream. And I guess we don't need to look at the Java code, but it's similar to what you've seen here in Python. You need to connect to the event session and do inserts. It's pretty straightforward, and it would be pretty easy to port to Python as well. So we're feeding data in, and we're doing it from a JSON file, but if your events are coming from some other service, it would be easy to plug that in and feed those events. Now, the key here, though, is that we're using this Db2 event stream because it's really tuned to allow a high rate of inserts. I'm running this on a laptop right now. This is a developer edition, but Spark and Db2 Event Store are meant to be run on clusters so they can scale. So now you have a platform where you can have a high rate of inserts for events. Now for querying the data, Db2 Event Store extends Spark to accelerate your analysis. So it uses indexes and synopsis data to provide better response time to your Spark SQL queries. So I think in addition to fast inserts, accelerated queries, it's also a comfortable environment to work in. Here we see some simple APIs. You can use different languages, and you can use a Jupyter notebook to ingest the data and do some analytics and do some charting. So I hope you'll clone the repo and give it a try. I think you'll see that we're doing a lot of simple things here, showing you how to create databases, drop databases, create tables, query tables, insert data. So it's fairly simple, and we try to keep it easy so you can go through it with as little bit of canned data. But what we're showing you is how to do something quite interesting if you have events pouring in and you want to do live analytics. And our nice little chart here, yes, it's live and it's showing you some changing data, but maybe it's not the most compelling use case. But if you have a live event stream and you need real-time data, this is the right kind of technology to put in place to get that done. And our final cell just uses that socket call to tell the event loader to stop inserting events. So that's the end of the notebook, and then you can Control-C to kill the daemon when you're done with it. So I hope you get a chance to try this and adapt it to your use case. I think there are a lot of pieces here that you can leverage, and you should be able to take this and innovate and come up with some great things.